Alright, so this is part 2 of the atoms online lesson. We talked already about the protons, neutrons, and electrons, kind of where you find them in the atom, and that it's the protons in the nucleus of an atom that determines which element that atom is. But I'd like you to look for just a second at these two hydrogen atoms. Now, both of these atoms are hydrogen atoms. They're both the same element, but I think that you would probably all agree with me that these two atoms are different from each other. So, since they're the same element, but they're still different from each other, we have to kind of talk about how that works. So how are these atoms the same yet different? Well, the way that they're the same is they have the same number of protons in their nucleus, which means they're the same element. But if you look, this hydrogen atom has a neutron in its nucleus, and this hydrogen atom does not. Now, if you remember from the first part of the video, both protons and neutrons have a mass of 1 AMU, 1 atomic mass unit. They both have a mass of 1. So let's look at the mass of these two atoms that we have down here. The mass of this hydrogen atom is 2, right? 1 for the proton and 2 because the neutron is 1. So 1 mass unit for the proton, 1 mass unit for the neutron is a mass of 2. But now look at this hydrogen atom. It's still hydrogen and has 1 proton, so there's nothing else that it can be. But because it has no neutron with its proton, then the mass of this atom is 1. So basically, if we wanted to be very specific about the names of these two hydrogen atoms, we would call this first one hydrogen 2, and we would call the second one hydrogen 1. And because their masses are different, but their number of protons are the same, we'd call them isotopes. So let me write that down here. Isotopes. Isotope. So the isotope, it's basically they're atoms of the same element that have different atomic masses. That's what an isotope is. So these are both the same element. They're both hydrogen, but this one has a mass of 2 and this one has a mass of 1. And the reason why their masses are different is because the number of neutrons in their nucleus is different. So because their neutrons are different, their masses are different, and because their masses are different, they're different isotopes of hydrogen. They're still both hydrogen, but they're different isotopes of hydrogen. So it gets kind of confusing. I mean, elements are types of atoms determined by how many protons they have in their nucleus. But then we find out now that you can actually have different types of those types. You can have different types of elements based on how many neutrons are in the nucleus and the mass that you get because of that, and those different types of elements are called isotopes. So another example, like my helium atom that I drew over here, it had 2 protons and 2 neutrons. So there's 1, 2 mass units for the protons, 1, 2 mass units for the neutrons. So the total mass for that is 4. So that would be helium-4. I could draw another helium atom, right? If I have 2 protons, 1, 2 protons, and then maybe instead of having 2 neutrons, let's say it had, oh, I don't know, let's just go nuts. Let's say it has 1, 2, 3 neutrons, and then you still have the electron cloud, and inside of that electron cloud you still have the electrons just kind of zipping around. Okay, so it still has 2 protons, which means that it's helium. 2 protons makes an atom helium, but now it's got 3 neutrons. So if we count all the particles in the nucleus, each particle in the nucleus is 1 atomic mass unit. So 1, 2, 3, 4, 5. That means that the name of this isotope, this specific isotope, is helium-5. Helium-5. Compared to helium-4 over here. It still has 2 protons, so it's still helium. Atomic number is still 2, but its mass is 5. So it's helium-5, a different isotope of helium. So the isotopes basically are atoms of the same element with different mass. That's the key. They have a different mass. Yeah. So we've talked about what an element is and how the number of protons determine what element the atom is. And then, if you know what element it is, we just talked about how you can figure out what isotope of that element it is based on how many neutrons there are and the mass of that atom. Now let's talk about another way that it can still be different. I'm going to scroll down here a little bit. Let's go back to our hydrogen atom for just a second. So the first hydrogen atom I drew had a proton, and it had a neutron, and then it had its electron cloud. And in that electron cloud, zipping around that electron cloud, there was an electron. Now remember, electrons are negative, and protons are positive. So if I have one electron, see, negative 1, and I have one proton, then that means the total charge of that atom is 0. And again, we call this charge. Right? These positives and negatives that I'm talking about with these particles, that's called charge. And so the total charge would be 0. Interesting. Well, I don't know if you know this or not. You may, but it's completely possible to have a hydrogen atom that is just a proton with no electrons zipping around it. So think about that for a second. There's no electron, right? So 0. There's 0 charge from electrons because there is no electron. And there's still the one proton, and protons are positive, so you get +1 from that, which means the charge for this hydrogen atom is +1. Huh. Interesting. And then something else that can happen, it may not happen as often as this scenario that I just described for you, but you can still have, your proton, right? And then you might have an electron cloud, and this time, instead of one electron in the electron cloud, there might be 2 zipping around out there. So now look at what we've got. For the electrons, which again are negative, electrons are negative, there's 2 of them, so that's -2. And for the protons, which are positive, there's 1, so that's +1. Whoops, didn't change my color there, sorry about that. So math skills here, -2 + 1 is -1. So what's going on here with these weird atoms? Normally, in a normal atom, you have the same number of protons as electrons. And because you have the same number, the charge is 0. Right? And that would just be, normally we just call those atoms. Right? We might talk about what element or what isotope the atom is, but usually we just call that an atom. But look what's going on over here. We've got this atom has a +1 charge, and this atom has a -1 charge. So charged atoms have a special name in chemistry. They're called ions. So this is an ion. It's a +1 ion. And this, whoops, is an ion. It's a -1 ion. And so how we would write that, it's still hydrogen. It has 1 proton, so it's still hydrogen, but we show that it's +1. Whereas over here, we just write H like that. And for this one, we show that it's -1 by putting a little minus up there. And those are hydrogen ions. And ions, you can have ions with all sorts of different elements, but the key is with ions, so when the protons are different, then you have different elements. And if the protons are the same but the neutrons are different, then you have different isotopes. If the protons are the same but the electrons are different, then you have different ions. So ions, it's all about this charge. Ions have the charge. That's what's really important there. They have a different number of electrons compared to their number of protons. And that causes them to have an overall charge. And so we call them ions. If you want to go even further in chemistry, we call positive ions cations. And then we call negative ones anions. All right, so that's it. We've got some pretty important vocabulary there out of the way. If an atom has a different number of electrons compared to its protons, then that's a charged atom, and we call charged atoms ions. If you've got elements with the same number of protons but different numbers of neutrons, they'll have different masses, and we call those isotopes. You have different isotopes of the same element, right? And anytime you have an atom, what element it is dependent upon how many protons are in the nucleus of that atom. So that's just a really quick atom refresher. If you've got any questions, as always, you can see me in class. Thanks for watching.